Hello, this video is all about Edexcel's large data set that we need for the statistics part of paper 3. So yes, as its name suggests, that the large data set is very large. It contains 8 different locations, 5 in the UK and 3 overseas. It's got 2 different time periods, May to October in 1987 and in 2015. And as you can see from the spreadsheet, lots and lots of different columns with different data. In this video, we're just going to be focusing on the May 2015 data for Heathrow to keep it a bit simpler. So the 5 UK locations, we've got Camborne down on the bottom left, we've got Heathrow in London, we've got Herne down on the south coast, we've got Leeming up in Yorkshire, I believe, and I don't know how you pronounce that, Lushar up in Scotland. And then overseas, we've got Beijing in the east of China, we've got Jacksonville southeast of the USA in Florida, and we've got Perth on the west coast of Australia. And notice that Perth is the only one in the southern hemisphere, and when we have our summer, they have their winter. So we're going to look at the individual columns. So the first column in the spreadsheet is the daily mean temperature. Don't need to worry about the first bit, about the air temperatures being recorded 1.25 meters above short grass. What's important is how they are measured. Okay, they are measured in degrees and tenths, so 9.8 on the 1st of May, 11.0 on the 2nd. If there were any negative values, i.e. ones below 0, they would be, of course, recorded with a minus sign in front of them, but there aren't any in Heathrow here. Any readings which weren't available would have been listed as NA. Again, there aren't any of those here. And the daily mean air temperature is the average of the hourly temperature readings between 9 o'clock in the morning one day and 9 o'clock in the morning this next day. Okay, and looking at the Heathrow data, apart from that first one, 9.8, they're all between 10 and 20 degrees. Daily total rainfall, again, we're looking between 9 o'clock one morning and 9 o'clock the next morning. You'll notice on the 3rd of May, it says TR, and that represents the word trace, which in itself is an amount of rainfall which is less than 0.05 millimeters, and if you're doing calculations you would normally just call it 0 millimeters. Again, NA would be not available data. One important thing to notice is that all of these units you need to be aware of. So the daily total rainfall is given in millimeters. Okay, you'll notice a few times it actually says 0 because they knew that, but if it was slightly more than 0 but still almost difficult to measure, they might TR. Daily total sunshine is measured as the amount of sunshine in a day between, as you can see, midnight and the following midnight. It's measured in hours and tenths, so there were 4.4 hours of sunshine on the 1st of May. That is 4 hours and 24 minutes, of course, not 4 hours 40 minutes. And 0.7 for the 2nd of May would be 42 minutes. 0.1 of an hour is 6 minutes. Okay, it's the amount of bright sunshine recorded on the day of entry. Daily maximum relative humidity. So the definition of humidity or relative humidity is a measure of how close the air is to being saturated with water vapor. So on the 1st of May, we had 79% humidity. On the 2nd of May, 93% of humidity. On the 3rd of May, it's 98%. And as you can see in the information, relative humidities of above 95% are associated with mist and fog. So we would associate the 3rd, 4th and 5th potentially with mist and fog. So far we've only seen individual columns. Now we see 4 columns all grouped together because they're related to each other. Daily mean wind speed and daily mean wind direction. They're not grouped together on the actual spreadsheet. I've done that. So on the 1st of May, the daily mean wind speed between midnight and the following midnight was 9 knots. 1 knot is 1.15 miles per hour. You need to know that conversion. They won't tell you it, but they might ask you to convert between knots and miles per hour. The daily mean wind speed using the Beaufort conversion, again between midnight and midnight, there's 0 to 12 on the Beaufort scale. It's a scale of wind speed, of course. 0 basically means there's hardly any wind, and 12 means there's lots and lots. It's very fast wind. But rather than use the actual numbers from 0 to 12, they have basically taken the wind speed and converted it into a word. So, for example, on this spreadsheet, we can see the words light, moderate, and fresh. 9 knots converts to light. 13 knots on the 3rd of May converts to moderate. 5th of May, 19 knots converts to fresh. Okay, that is qualitative data because it's qualities rather than quantitative. The daily mean wind direction, obviously that is the average of the wind directions throughout the day. On the 1st of May that was 60 degrees. It's a bearing, so it's measured from north. All the data in that column will be to the nearest 10 degrees, so 60, 90, etc. And then in the final column, that wind direction as a bearing has been turned into some sort of cardinal direction, some sort of compass point. We know the basic ones, the north, south, east and west. We know the ones in between, the northwest and northeast and so on. So for some of these though, like the first one, on the 1st of May, ENE stands for east, northeast, and that is basically between northeast and east. And when you're doing one of these three ones, like the ENE or the SSW, it starts with the main compass point, your north, south, east or west, and then you follow up with your in-between compass point. So east, northeast is between east and northeast, which of course 60 degrees is. Similarly, we have three columns relating to the daily maximum gust and the daily maximum gust direction. So the difference between this and the previous slides is that the maximum gust speed is the maximum instantaneous speed that occurred, whereas in the previous slide we were looking at the average, the mean wind speed. So on the 1st of May, the daily maximum gusts between midnight and midnight was 21 knots. Again, we need to know how to convert that into miles per hour. And then again, we've got two columns relating to direction. The first one, again, the nearest 10 degrees, showing the direction for that particular instantaneous maximum gust and its cardinal direction. So far, all the numerical data we've seen has been continuous. So although it's been rounded, it has been based on continuous data. Cloud cover is discrete. Okay, it's measured in eighths or octas. Obviously, octagon, well, October does come from the number 8, however confusing that might be. And cloud cover is the fraction of the celestial dome covered by cloud. So there are 9 possibilities, 0 to 8. So 0 cloud cover basically means that there is no cloud cover at all, whereas 8 would mean that it was completely cloudy and nothing else would be able to get through. And as you can see from the column, on the 1st of May, the daily mean total cloud cover was 5, which corresponds to 5/8 of the celestial dome covered by cloud, and so on. But as I say, the most important thing probably about this set of data is that it is discrete. Visibility is defined as the greatest distance at which an object can be seen. There's a paragraph about how it's measured. It's measured horizontally, but then that makes sense because it would be a bit daft if it was vertical, because you can look up and see the moon at night, and that is certainly further away than we're talking about here. So we are talking about horizontal distances. The values are noted in decameters, dm. 1 decameter is 10 meters. It says a dash indicates data not available, but I haven't actually found any data which isn't available for this column. So on the 1st of May, there were 3,100 mean visibility in decameters and so on. It looks like all the data is rounded to the nearest 100. And then our final column, pressure. Pressure is measured in hectopascals, where 1 hectopascal is 1 millibar. 1 hectopascal is 100 pascals. Pressure used to be measured in millibars and bars, but now it's measured in pascals and hectopascals. On the 1st of May 2015, the daily mean pressure was 1,011 hectopascals. Just to give it some context, standard atmospheric pressure is about 100 kilopascals, which would correspond to 1,000 hectopascals. So finally, let's have a look at some ways that you might be expected to use this data or talk about the data. So most of the data is quantitative, which means that you could calculate things like the mean, the standard deviation, the variance, the quartiles, the interquartile range, and so on. The discrete uniform distribution could be used for your cloud cover. As I say, that goes from 0 to 8 in discrete eighths. Each would have a probability of a 9th. You could work out the correlation coefficients between two columns. You could be given a regression line and have to work out a value by interpolation, or explain why extrapolation might not be a valid idea. You might have to interpret the gradient and y-intercept for a regression line. And then there's lots of things that you need to know, for example. So I've mentioned that 1 knot is 1.15 miles per hour. So you need to know that. You need to know the unit, so rainfall in millimeters, pressure in hectopascals, etc., sunshine in hours. You need to know what NA means, so not applicable, and what TR means for your rainfall. So that's a trace, something less than 0.05 millimeters. And then in terms of talking about the data, I've mentioned NA. You might be asked for some of the limitations of the data. So the fact that some of it isn't available is, of course, a limitation. Other limitations are about the time and the place. So we've got 5 locations in the UK and 3 overseas. We've got the time intervals from May to October 2015. Well, let's say that you were given the spreadsheet in front of us and asked to, why it might be a limiting factor if you were trying to work out, say, the maximum relative humidity in the UK. We've only got Heathrow here, so we might want to use the other 4 weather stations. If we're talking about maximum relative humidity throughout the year, then we do have other months available to us. So that's one benefit of the large data sets. However, we don't have November to April, so it's a limitation of your large data set. And if we were looking at daily maximum relative humidity over the last 50 years, we do only have 2 years worth, or 2 6-month period amounts of data. Similarly, if we were thinking about, China, we have got Beijing data, but we haven't got anywhere else in China. So that's one limitation. Okay, so good luck, have fun, and take care.